Welcome to the Copperfield Electric Podcast. Imagine dropping 5 or even 10 grand to prep your home for a shiny new EV in the driveway.
Oh, yeah. Or getting your roof ready for a massive solar array.
Right. The equipment is mounted, the drywall is patched, and you're, ready to finally flip the switch and step into the future.
And then the city inspector walks in.
Yeah, they shine a flashlight into that gray metal box on your wall and fail your entire project because of a single slightly loose screw.
It happens all the time. I mean, to the homeowner standing there looking at that failed inspection sticker, it feels like pure agonizing bureaucracy.
Oh, absolutely. It is incredibly frustrating.
But that gray metal box, the electrical panel, it's essentially the central nervous system of your entire house.
Right.
If that system has even a microscopic flaw, absolutely everything attached to it, including the physical structure of your home, is at risk. It's not just a box holding some switches.
Yeah, it's a highly engineered, deeply scrutinized safety device, which honestly is exactly our mission for today's deep dive.
Sounds good.
We are unpacking what really goes down when the city inspector shows up after you've upgraded your home's electrical panel. We're looking at what they actually check, the fascinating physics of why they check it.
Which is my favorite part.
Oh, for sure. And we'll also cover how partnering with the right local professionals, specifically the team at Copperfield Electric here in Orange County, is really the only way to guarantee you pass this rigorous final boss of home renovations.
It really is the final boss, and for good reason, The demands we're placing on our homes today are just unprecedented in the history of residential construction.
Right. So let's start exactly there. Because we are seeing this massive wave of panel upgrades across the country, it feels like everyone is suddenly ripping out their old boxes.
Yeah, everyone's upgrading to a 200 amp service.
And it makes sense conceptually. When I look at a modern home's electrical demand, you've got the EV chargers pulling massive loads, solar setups feeding power back, high demand induction stoves, multiple HVAC zones.
It's a lot of juice.
It is. It's honestly like trying to run a high-end gaming PC on a flip phone battery. The old 100 amp or even those ancient 60 amp systems in older homes, they just were not built for this kind of relentless high-capacity draw.
No, they definitely weren't.
But I have to ask, is the city inspection process keeping pace with this? I mean, is it a genuine physical safety check? Or are municipalities just, seizing an opportunity to collect permit fees on a booming trend?
Oh, it is absolutely a physical safety check. And understanding why requires looking at how modern devices actually consume power.
Okay, lay it on me.
Your gaming PC analogy is spot on, but let's take it a step further into the physics of how electricity behaves over time. The inspector's job is fundamentally about life safety.
So preventing fires before they start.
Exactly. Think about it. When you plug in a toaster, it draws a lot of power, but only for maybe 2 minutes.
Right.
But when you plug in an electric vehicle, it might draw an enormous amount of power continuously for 8 to 10 hours. That continuous draw creates a completely different thermal dynamic inside your walls.
Because it's pushing electricity through the wires for so long that they actually start to heat up?
Yes, exactly. And the National Electrical Code, which is what the inspector is strictly enforcing, has very specific rules about what they call continuous loads.
Which is anything running for, a few hours?
3 hours or more, yeah. The code mandates that a circuit can only be loaded to 80% of its maximum capacity if the load is continuous.
Wow, only 80%.
Yeah, specifically to manage that heat buildup. So a panel upgrade isn't just about taking an old metal box off the wall and throwing a bigger box in its place so you can plug in more toys.
Right, there's more to it.
It's a strict, uncompromising mathematical equation. The inspector is stepping into your home to ensure that the panel can truly handle the complex load calculations required by all these new devices.
Okay, so when you say load calculations, you're talking about the literal math of what the house could potentially ask the panel to deliver all at once. It's not just like adding up the numbers printed on the breakers, is it? Because if you add up all the breakers in a house, it almost always exceeds the main panel's rating.
Precisely. Because you don't run your oven, your air conditioner, your EV charger, every light bulb, and your hairdryer at the exact same millisecond.
At least I hope not.
Exactly. So the code uses a complex formula. It's based on the square footage of your home, the types of appliances, and the specific high-draw additions to calculate a safe maximum load.
Got it. And the inspector is checking that math.
Yes, they are verifying that the electrician did that math correctly. If the calculations are wrong, the system could allow you to draw more continuous power than the internal components can physically handle.
Which leads to overloaded circuits, I imagine.
Yeah, overloaded circuits, which degrade the insulation on your wiring, and ultimately that leads to catastrophic electrical fires. The inspection is really a mathematical verification that your home won't try to pull more power than the copper can safely deliver.
Okay, so that's the theoretical math part of the inspection. But I want to know what happens when the inspector actually opens the panel door.
The physical check.
Right. Because earlier, I joked about failing an inspection over a loose screw. But looking into the inspection guidelines from our sources, they really do demand tight, correctly sized wiring and connections.
They do, very strictly.
And honestly, to a layman, this sounds incredibly nitpicky. I mean, if a wire is pushed into the breaker and it's clamped down and the lights turn on, isn't that enough?
You'd think so, but no.
Why on earth is an inspector scrutinizing the tension of a tiny screw inside the panel?
Because of the microscopic physics of electricity.
Yeah.
It isn't like water flowing through a pipe, where a slightly loose fitting just results in like a small harmless drip on the floor.
Right, a puddle won't burn your house down.
Exactly. When a screw is even slightly loose inside an electrical panel, or if a wire isn't making full, perfectly compressed contact with its metal terminal, you create microscopic air gaps.
Air gaps, okay.
And electricity is incredibly determined. It desperately wants to jump across those gaps to complete its circuit. And when electricity jumps through the air, it's called arcing.
Ah, okay. And arcing is essentially a miniature lightning bolt inside your panel, right?
That is exactly what it is.
Mhm.
And lightning is incredibly hot. Even if it's not a full, visible arc, squeezing electricity through a compromised loose connection creates immense resistance.
And resistance equals heat.
Yes.
Yeah.
In an electrical system, resistance translates directly into heat. A loose connection acts identically to the glowing orange heating element inside your toaster.
Oh, wow. That is a terrifying visual.
It is. Over hours of charging your EV, that tiny bit of resistance creates what electrical professionals call dangerous hotspots.
Which causes the metal to expand and contract as it heats up and cools down, right? Meaning the loose connection gets even looser over time.
Yes, thermal expansion makes the problem exponentially worse. Those hotspots slowly melt the protective plastic insulation around the wires. They warp the metal components of the panel, and eventually they ignite the surrounding building materials. That is why the inspector is checking those connections.
So they're looking for the literal root cause of a fire.
Exactly. In fact, professional electricians use specialized torque screwdrivers to tighten those lugs to the exact inch-pound specifications required by the manufacturer. And the inspector is looking for evidence that this precision was followed.
Okay, I want to clarify something here because I've heard this misconception that inspectors show up with like massive testing rigs to simulate a heavy electrical load and see if the breakers pop.
Oh no, definitely not.
Right, that's not really how a standard residential inspection works. They aren't intentionally trying to blow your circuits.
No, they are not hooking up simulation machines to push your house to the brink. When we talk about verifying breaker functionality, it's about visual and mathematical verification of the safety mechanisms.
Okay, making sure the parts are right.
Right. The breaker's entire job is to detect an overload and physically break the circuit to trip before that toaster effect we just talked about can happen in your walls. The inspector verifies that the breaker matches the wire gauge perfectly.
Let's break that down because from what I read, that is a massive failure point. Wire gauge versus breaker size.
It's huge. Think of the breaker as the bouncer at a club and the wire as the hallway leading inside.
Okay, I like this.
If you have a thin 14-gauge wire, it can only safely carry 15 amps of current before it gets too hot.
So the hallway is narrow.
Exactly. If an amateur installs a 30-amp breaker on that 13-gauge wire, the bouncer is going to let 30 amps of electricity flow through.
Uh-oh.
Right. The breaker thinks everything is fine because it hasn't hit its 30-amp limit. But the hallway, the 14-gauge wire, is already melting and catching fire at 20 amps.
That is a brilliant analogy. So the inspector is meticulously checking that the bouncer and the hallway actually match.
Precisely. A 15-amp breaker for a 14-gauge wire. A 20-amp breaker for a 12-gauge wire. If they spot a mismatch, it is an instant failure because the safety mechanism is entirely compromised.
That makes complete sense. The physical components have to align perfectly with the math. But here's an area that completely fascinates me.
What's that?
There is an entirely separate, invisible system happening inside that box that isn't even meant to carry electricity during your normal day-to-day life. I'm talking about grounding.
Oh, grounding is vital.
Digging into the electrical codes, grounding is highlighted as a massive, non-negotiable priority for inspectors. To visualize this, I think about a massive hydroelectric dam.
Okay, I see where you're going.
Proper grounding is essentially the emergency spillway. When there's a massive flood or a sudden uncontrollable surge of water, you need a safe, dedicated path to direct that dangerous overflow away from the town and safely into the riverbed.
I love that.
In an electrical system, grounding directs dangerous stray electricity safely into the earth rather than into you, the homeowner.
That is a brilliant way to visualize it. Grounding is your invisible emergency shield. It protects both people and equipment by providing the path of least resistance.
So how does that play out in real life?
Let's say a wire comes loose inside your metal washing machine and touches the outer casing. The entire machine is now electrified.
Yikes.
Yeah. If you touch it and the system isn't grounded, your body becomes the path of least resistance to the earth. You receive a lethal shock.
But if it is grounded?
And if the system is properly grounded, that stray electricity instantly flows down a dedicated copper wire straight back to the panel and down into thick copper rods driven deep into the soil outside your house.
Because electricity is lazy, basically.
Exactly. Electricity will always take the easiest path, and the thick copper wire leading to the earth is much easier to travel through than a human being. The sudden massive flow of electricity to the ground also causes the breaker to trip instantly.
Which shuts off the power and eliminates the danger entirely.
You got it.
And the inspector is out there checking those literal copper rods in the dirt.
Absolutely. They are verifying the size of the grounding wire, the depth of the rods, and how the system is bonded to your home's metal water pipes.
Wow, they really check all of that.
Oh, yeah. Missing or inadequate grounding is one of the most common reasons a panel will fail an inspection, simply because the risk of shock is too great. The inspector wants to see that emergency spillway built to exact code specifications.
Okay, so we have the physics, the microscopic gaps causing heat, the load calculations preventing overloads, the grounding spillway. But there is also a very human element to what the inspector is looking for.
The accessibility side of things.
Right. A lot of inspection failures actually come down to how humans interact with the panel in an emergency. For instance, clearance and accessibility.
Yes, and this happens constantly in older homes where space is tight. People want their electrical panel out of sight.
Naturally, they aren't exactly pretty to look at.
True. But the National Electrical Code is rigid about this. You must have a clear working space around the panel. Typically, that means 36 inches of clearance in front of it, 30 inches of width, and clear headroom.
So you can't just hide an electrical panel behind a permanent bookshelf or install it over the washing machine?
No, definitely not. You can't put it inside a cramped coat closet where you can't open the door fully either.
Because if a fire starts, nobody cares about your interior design.
Exactly. In an emergency, if your house is filling with smoke, or if an appliance is actively sparking, you or the fire department need to be able to reach that panel instantly.
Without moving boxes or squeezing past a dryer.
Exactly. The inspector will fail a perfectly wired, perfectly grounded panel if it doesn't have that dedicated, empty physical space around it.
And then there is the labeling. The code is surprisingly strict about how you write on the panel door.
It is. Again, think about human behavior in an emergency, or even just during routine maintenance.
Like trying to fix an outlet.
Right. If you need to shut off the power to a sparking outlet in the kitchen, you do not have time to flip 30 different breakers trying to find the right one.
And you certainly can't rely on breakers labeled unknown or MISC or, faded, illegible handwriting from 1995.
No, you cannot. Clear, accurate labeling of every single circuit is a strict code requirement.
And if you're adding something modern, like solar panels, the labeling requirements get even more intense.
Oh, wait, vastly more intense.
Because you now have power coming into the panel from two different directions, the utility grid and your roof.
That is a critical point. Solar panels backfeed electricity into your system. If a utility worker shuts off power to your street to fix a line, they need to know for an absolute certainty that your solar panels aren't going to suddenly push live current back out into the neighborhood grid.
Oh, wow. Yeah, they could get electrocuted by your house.
Exactly. So the inspector needs to see specific permanent warning placards, a complete schematic of the system, and clear disconnect switches. The human element of how we document the system is just as important as the copper wire.
Which brings us to the ultimate reality check for anyone listening. We've covered a massive checklist of potential failure points
A
here.
very long list.
Right. Improper torque causing microarcs, flawed load calculations, mismatched wire gauges, inadequate grounding rods, blocked access, and sloppy labeling.
That's a lot that can go wrong.
Knowing all the incredibly detailed ways an inspection can fail leads to the obvious question. How do you guarantee you pass on the first try? Because failing a city inspection doesn't just mean a bruised ego.
Not at all.
It means costly project delays, scheduling re-inspections, paying additional permit fees, and potentially sitting around for days without power.
The only way to navigate that minefield is to avoid doing it yourself.
Yeah.
And, frankly, avoid hiring the cheapest handyman you can find. You have to work with licensed professionals who know the local municipality-specific codes inside and out.
And this is where we look at a company like Copperfield Electric. They are the prime example of exactly who you want in your corner for a massive infrastructural change like this.
Definitely.
But I want to push back on something that gets thrown around a lot in marketing, and that's the concept of being licensed. I see license numbers slapped on the sides of beat-up vans all the time.
Oh, sure.
To a homeowner, it's just a string of digits. What does having that specific state license actually guarantee when the city inspector shows up?
That is a great question, because a true license is far more than a marketing tactic. Copperfield Electric holds a specific verifiable license in California license number 1094740.
Okay, so what does that number actually mean to the inspector?
What that means to the city inspector is that the person who pulled the permit and did the work has passed rigorous state testing on the National Electrical Code.
So they know the math.
Exactly. They understand the continuous load math. They understand the grounding physics. It also means they are legally accountable, bonded, and insured.
That makes a lot of sense.
When an inspector sees a known, reputable local license number on the permit, they know they're looking at professional, code-compliant work, not a weekend DIY experiment.
It changes the entire tone of the inspection. And looking at Copperfield's operations here in Southern California, there is something else that stands out, though it requires a bit of healthy cynicism to appreciate.
Which is?
They explicitly highlight their commitment to honest troubleshooting, meaning they will only diagnose a problem if it truly exists. It's almost sad that we have to highlight honesty as a premium feature in the contracting world, but given the stakes of electrical work, it's vital.
It is unfortunately very necessary to highlight. Because the physics of electricity are invisible and highly complex, it is incredibly easy for a predatory contractor to use the threat of an electrical fire to upsell a homeowner.
Right, the scare tactic.
They might look at a slightly older panel and say, oh, this entire thing is a hazard. You need a complete $6,000 replacement immediately. When in reality, the issue might just be one faulty, incorrectly sized breaker that costs $50 to replace.
Right. And Copperfield's reputation is built on avoiding those scare tactics. They do the precise math. If your load calculations genuinely require a 200-amp panel for that new EV charger, they will do it flawlessly.
Yep.
If you just need a sub-panel, they will tell you. That honest troubleshooting saves homeowners a massive amount of money.
And they back it up with availability. Electrical emergencies, like a breaker constantly tripping or a sudden loss of power on half your circuits, they don't conveniently happen between 9 and 5.
Definitely not. Usually it's at midnight on a holiday.
Exactly. Copperfield offers 247 emergency electrical services, so you aren't left in the dark waiting for business hours.
Plus, they know the specific local quirks of the municipalities they serve. They have a massive footprint across Orange County.
A really wide coverage area.
Yeah, they are dealing with city inspectors in Irvine, Anaheim, Santa Ana, Costa Mesa, Newport Beach, Laguna Beach, Mission Viejo, Tustin, Huntington Beach, and Fullerton.
That local geographic knowledge really matters.
Oh,
For example, preparing an outdoor panel for inspection in a coastal city like Newport Beach or Laguna means the electricians aren't just checking tightness. They are actively mitigating salt air corrosion.
Oh, I didn't even think of that.
Yeah, it's a massive failure point for local inspectors by the beach. A contractor from 3 counties away might not anticipate that strict local scrutiny.
That makes total sense. At the end of the day, Copperfield's goal aligns perfectly with the city inspector's goal, ensuring every project meets the strictest safety codes so that your home is efficient and safe.
Exactly. They handle the thermodynamics, the torque wrenches, and the intricate math, so you just plug in your car and go to sleep without worrying about the walls getting hot.
So let's summarize the journey we've taken today. Upgrading your electrical panel to adapt to the modern world is a necessary high-stakes surgery on your home's central nervous system.
Well said.
Passing the city inspection isn't about arbitrary rules, it's about verifying the physics of safety. It requires flawless, tight connections to prevent arcsing and heat.
And verified mathematical load calculations so your wires don't melt.
Right, it requires a perfectly executed grounding system acting as an emergency spillway and clear, accessible labeling for human intervention.
And the single best way to ensure all of those invisible systems are perfectly aligned is to rely on verified, licensed professionals like Copperfield Electric to handle the heavy lifting.
Absolutely. It's about respecting the power of the grid and removing the stress of the inspection by relying on actual expertise.
100%.
And for you listening at home, there are practical steps you can take today, even before an inspector or an electrician ever sets foot in your house.
Go look at your panel.
Yes. Make sure you have that 36 inches of clearance. Move the brooms, the boxes, and the coats out of the way. Open the door and look at your labels.
Do they actually correspond to the rooms in your house, or is it a mystery?
It's a small 10-minute step that brings a huge amount of safety awareness to your daily life.
Discussing all these physical requirements, the torque, the copper wires, the physical clearances, it raises a really fascinating thought about where we are heading in the next decade.
Oh, what do you mean?
Well, if our electrical panels are essentially becoming advanced command centers, literally communicating with the smart grid, balancing solar output, and prioritizing energy to our cars,
Yeah.
will the home electrical inspections of the future look less like a traditional wrench and wire physical check
Yeah?
and more like an IT cybersecurity and software audit to ensure your home's power grid can't be hacked?
Oh, wow. Wait, really? From tightening screws with a torque wrench to checking firewall configurations and firmware updates on your breaker box.
It's a logical next step.
That is a wild and very real thing to think about. But until that day comes, make sure those physical connections are tight. Thanks for taking this deep dive with us today. Stay curious, stay safe, and we will catch you on the next one.